Okay, we're in section 9.2, simplifying square roots. All right, so my goal here in this lesson is to introduce you to this concept. It has a lot to do with perfect squares, which is why we've been reciting them in class, so we have those memorized. We can memorize them because those values never change. From 1 to 15, we have a set number of perfect squares, okay? So with simplifying square roots, it's important that we understand what a perfect square is because we're looking for those numbers to be factors of other numbers. All right? Your calculator will be important in this lesson, but there are steps that you have to show on your homework assignment that the calculator will not show you. If you don't show those steps, you won't get credit on this homework assignment. Not because I want to be mean or give you extra work, but because I need you to understand the why behind the concept. Okay? So that's important. The first thing I need you to understand is that the square root of 4 times 16 is the same thing as the square root of 4 times the square root of 16. Basically what they're saying is that I can break it up into separate square roots so I can take maybe the square root of part of the expression. All right, so do you see what I'm saying here? Whether it's under one radical or two radicals, it's the same thing. All right, and you need to know what a radical is. That's the square root symbol. All right, so an example, real quick, the product property of square roots. So it's important that we understand this property. Why? Because it tells me the reasoning behind what we're doing. And with anything in math, you can't just do something because it looks like it's going to be the right answer. It has to follow a set of rules. So with taking the square root, and you can just abbreviate this, but you're looking for the expression to be in simplest form. How do you know? No expression, no number under the radical sign has a perfect square factor other than 1. 1 is not going to really change any value there. Okay? No factor of the expression under the radical sign has any perfect square factor other than 1. All right, and that'll make more sense in a second. Another thing is you cannot have a radical in the denominator. Okay, so you could just write in your notes, no radical signs in the denominator. All right, that's important. Okay. So nothing under the radical that has perfect square factors and no radical sign in the denominator. That's how you know if the expression is in simplest form. All right, so example 1 doesn't necessarily start off with the easiest numbers, does it? Square root of 180, but here's what I know. The square root of 180 was this number in my perfect square list. Is 180 a perfect square? 180. No, it is not. But it is not in simplest form because there are factors of this number that are perfect squares. So here's my goal. I need to break up 180 into a perfect square factor multiplied by some other number. I've got to figure out what it's going to be. And here, with the really big numbers, here's a shortcut in how we can figure it out. Otherwise, it's going to be a ton of trial and error, and it's just really difficult. With a really large number like this, I want you to put it into your calculator first. Do the square root of 180. And what does it give you? No, under the radical. We're not looking for the decimal. 6, we don't say 6/5, we say 6 to the square root of 5. That is my answer, okay? But this step in between is the step I'm looking for on your homework. So you can't just skip this step. Well, here's how you backtrack. How could what number, I know one of these is a 5 because that one's in there, but what number would have been underneath the radical in order for me to take the square root of it, and the square root was 6? What number would have had to be under the radical? 36. So we're going to backtrack. If 6 is the square root that I took out of the radical, that means 36 had to be under the radical in that middle step. Okay? Hang in there with me. All right? Here's why this makes sense. In your calculator, I want you to multiply. What is 36 times 5? Multiply it in your calculator right now. What do you get? 180. These two steps don't change any value. All you're doing is breaking it down so that one of the factors is a perfect square. Well, in this case, because it's a really large number, would you agree that this would have been difficult to just come up with? 36 times 5, okay, to find it out of nowhere, not really having much to go on? Yes. So that's why we start here, and the reason we know it's 36 is because we had to take the square root of something to get 6 on the outside. So what if 7 had been on the outside? What would my factor have been? 49. Okay, so now let's do the next one. 300. Okay, again, you have to multiply a perfect square factor times some other number. All right, put it in your calculators first if you need to. This one you might be able to even do mental math. Some people might be able to if they think about it. All right, put it in your calculator. Get it out. What did you get for your answer? 10 square root of 3. But again, I'm going to say this again. If this is all you write on your homework, you're not going to get credit. You're going to have to redo it. This middle step is important to me. Why? Because it tells me that you understand where this 10 is coming from on the outside. What would be my perfect square factors of 300? 100 times 3. Does everybody agree that this is the same thing? Square root of 300 and 100 times 3. That's the same thing. All we're doing is 300 is not a perfect square. But I can break it down to a factor that's a perfect square and take the square root of that. And that's why the number is on the outside in my answer. Are you following me? Okay, in a nutshell, that's the whole lesson today. That's really important for you to understand. Do the last one now. Right, square root of 882. Again, I don't mind if you skip over here to the answer, okay? In your calculator, what did it give you for your answer? 21, not 21/2, guys, to the square root of 2. Now, what does that mean about your perfect square factor? 441 times 2. Okay, so we're breaking down a larger number into its factors, and one of the factors is a perfect square. It's not in simplest form until what's under the radical doesn't have any other perfect square factors. And an acceptable answer is not, oh, well, that's what my calculator told me, okay? Oh, just look at your calculator. No, you need to understand why. 21 is on the outside because I could take the square root of one of the factors of 882. Does that make sense? Okay. All right, example 2. We're going to throw in some variables. Okay. And we're going to keep them all squared. I meant to change this. Okay. So the number part. And I don't know why they do this, but once they put in variables, they like way simplify the numbers. Okay. 24. Do you need a calculator to give you the factors that can be multiplied together to be 24 and one of them is a perfect square factor? Before you answer that, how many perfect squares are there even that are less than 24? There's only like 4 of them. So which one of those numbers is a factor of 24? You only have 4, 9, and 16. That's it. You only have 3 possible numbers. Which one of them is a factor of 24? 4. Okay, you don't need a calculator to figure that out. Okay, so you don't have to skip over to the answer. And by the way, your calculator can't do variables anyway. The square root of 4 times the square root of 6 times s squared. All right, so now I broke it down. Well, can I take the square root of 4? What is the square root of 4? 2. And I can also take the square root of s squared. S squared is the same thing as s times s, just like this square root of 4 was 2 times 2. So what is the square root of s squared? S. So 2s to the square root of 6. This meets my criteria because 6 is not a perfect square and it has no perfect square factors. This is the radical expression in simplest form. Do the second one. 32x to the second power simplified. Figure out how it breaks down. So 16 times 2. We just talked about the fact that 8 times 4 would not be the best choice because 8 has another perfect square factor in it. So I'm going to have to do it multiple steps. You want to choose the largest perfect square that goes into that number. So times x squared. All right, so the square root of 16 is 4. Pull out your x to the square root of 2. Who got that right? 4x to the square root of 2. Now on the last one, we're going to change this one up because it's too much like the first one. I'm going to do 98 x squared y. 98x squared y. Okay? All right, so break down 98. And then your x and your y, you're going to split them up, each under their own radical. Each term goes under their own radical. All right, so for 98, I go square root of 49 times the square root of 2 times the square root of x squared times the square root of y. So which terms in here can I take the square root? 49 and x squared. So those I'm going to pull out. What's the square root of 49? 7x to the square root of 2y. Y had to stay inside because there was only one y. X had 2, so I could pull that one out. All right, any questions? Example 3, quotients. Okay, here's what I need you to look at on this slide. You don't have to write it down. The square root of 100 over 4 is the same thing as the square root of 100 over the square root of 4. So that way, if one side of the fraction is not a perfect square, but the other side is, you can still take that side. Okay? This is what it looks like in example 3. The square root of 13 over 36. So here's what my rule says. I can split it up. I can do the square root of 13 over the square root of 36. That's it. And when I do that, okay, can I take the square root of 13? Can I take the square root of 13? No, there's no square root of 13. Check it in your calculator. There isn't. So I leave it. But can I take the square root of 36? Yes. 6. That's my answer. Okay? So it allows you to split it up, to break it up, to take the square root of your perfect squares and then to simplify the other side. All right? Go ahead and try to do the second one. All right, so I break it up, square root of 50 over 9. Okay, right? Well, let me do it this way. Square root of 50 over the square root of 81. Okay, can I take the square root of 81? Yep. This is not my final answer.
You gotta get effective.
Because 50 can be further simplified. Okay? If you're unsure about that, put it in your calculator, but you have to show this step on your homework. Guys, I'm trying to make this as clear as I can. You have to show me square root of 25 times the square root of 2. That shows me you didn't just punch it in your calculator. You can put that over 9. So 5 square root of 2 over 9. I need you to understand why the number is outside the radical sign. Why do I have a 5 on the outside? Why?
It's a perfect square root.
Yes, because there was a factor of 50 that was a perfect square. So I could take the square root of that number, but it wasn't an even square root, so there were leftovers.
Oh, so your leftovers.
You see that? Your leftover is the square root of 2, yes. Okay? All right. Do the last one. 18 over 25. Make sure it's completely factored. Square root of 18. Square root of 25. So the denominator is easy. It's going to be 5. But the square root of 18, how could I break that down? It's not a perfect square. 9 times 2. Three square root of 2 over 5. 3 square root of 2 over 5. Yes. That you don't get credit on your homework, okay? Quiz and test, we'll look at that when we get to it. But on your homework, guys, this right here, this step where you show the breakdown, that's important. If you don't show that step, you're not showing me that you fully understand this concept. Where do my perfect square factors come into play? You've got to show me that step, and then your calculator's not going to give you that. Okay? All right, that's it for example 3. Okay, in example 4, we have a word problem. I need you to follow along. I don't want to hear a bunch of after I ask the question. It's not that difficult. We just follow along. After a car accident, a police officer measures the length of the skid marks of the car's tires. The expression square root of 27L gives the car's speed in miles per hour at the time the brakes were applied. Write that expression in simplest form. So we've done this all class. Write the expression in simplest form. All right, 3 square root of 9 times the square root of 3 equals 3 times the square root of 3L. The L stays underneath. It's not a perfect square. So now use your simplified expression to answer the second part. The car's skid marks are 125 feet long. Use the simplified expression to approximate the speed when the brakes were applied. Go ahead and do that. Use the simplified expression, 3 square root of 3L. They give you a value. Now approximate the car's speed. All right, so we make our substitutions. 3 times the square root of 3 times 125. 3 times the square root of 375. Now, here's where this answer is a problem. I'm pretty sure 375 you can take some factors out too, but don't worry about that. All right, what if you were the police officer and you went up to your sergeant and you said, sir, I did the calculation and the car was traveling approximately 3 times the square root of 375 miles an hour. What would he say to you?
You're fired.
Why? Not you're fired, but what do you say? Oh yeah, that sounds great. Does that make any sense to him? No. So there's a formula, listen, so there's a formula to use, but this answer is not practical. So I need to convert this answer now to the decimal form and round to the nearest mile per hour to really get a practical answer. What would that be? About 58 miles per hour.
And you did more.
I did that because they want to know how fast the car was going. A square root answer, it doesn't make sense. Okay? Depends if it was a 30-mile-an-hour speed zone.
I actually was reading if you increase your speed, that's 9 times more of force than your bike. How'd you get 50?
That's a lot. 58, I changed 3 times the square root of 375 to a decimal. Okay, what if you had x, the square root of x to the 5th power? Okay, here's what you're going to do. You're going to break down the 5th power into pairs of 2. So how many pairs of 2 can you get out of 5? I'll get it in a minute. I got to finish this. Okay, square root of x squared times x squared. Well, what's 2 plus 2? 4. And then you have one more square root. Okay, so 2 plus 2 plus 1 is 5. So that's the same thing. Now I can take the square root of x squared, the square root of x squared, and then I have the square root of x left. Okay, now here's the important part. What is x times x? Not x plus x. What is x times x? X squared. Okay? All right, so you might want to rewatch that, but that will help you on number 30 on your homework tonight.